What is Pseudorange in space tech GPS navigation? Have you ever wondered how your GPS device knows exactly where you are? One key concept that plays a vital role in this technology is called pseudorange. So, what is it, and why is it important? Let's break it down. Pseudorange is the distance that a global positioning system satellite measures to a GPS receiver. This distance is calculated by timing how long it takes for a signal to travel from the satellite to the receiver, and then multiplying that time by the speed of light. The term pseudo is used because this measurement is not the exact geometric distance. Instead, it includes various errors that can occur during the signal's journey. Each GPS satellite continuously sends out signals that include the exact time the signal was transmitted. These satellites use highly accurate atomic clocks. When a GPS receiver gets this signal, it records the time it received it using its own clock, which is usually less precise. The difference between these two times, when multiplied by the speed of light, gives us the pseudorange. However, because the receiver's clock is not perfectly synchronized with the satellite's clock, this distance is not entirely accurate. Several factors can cause the pseudorange to differ from the true distance. One major factor is the clock errors in the receiver. Most GPS receivers use quartz oscillators, which are not as accurate as atomic clocks. Another factor is signal delays caused by the Earth's atmosphere. The ionosphere and troposphere can slow down the signals, leading to discrepancies. Additionally, signals can reflect off surfaces before reaching the receiver, known as multipath effects. Lastly, errors in the satellite's orbital position can also affect the measurements. To get an accurate position, the GPS receiver needs to calculate pseudoranges to at least for satellites. By using these pseudorange measurements along with the known positions of the satellites, the receiver can solve a set of equations. This process helps estimate its own three-dimensional position and corrects for the clock offset. This method is known as trilateration and is essential for GPS navigation. In practical terms, pseudorange measurements are the foundation of how GPS positioning works. Even though they are not perfect, they provide the initial data needed to determine accurate locations on Earth after correcting for errors. Understanding pseudorange is essential for improving GPS accuracy and developing advanced navigation systems. So next time you use your GPS device, remember that pseudorange is a fundamental concept that helps you find your way. It's fascinating how this technology works behind the scenes to keep us on track.